Hello, welcome everyone. My name is Dhimandev Goswami, and this is my channel, The Common Math. And in one of the previous videos, I was talking about postulates and axioms, and I also stated about that Pythagoras was the first person who actually laid down the basic idea of how to come up with proofs. And so, so now let's try to prove something. Okay, so I have a question that prove it is impossible to find two whole numbers, two whole numbers such that the square of one of them is equal to twice the square of the other. Pardon my handwriting. So I just wanted to write down, because this question is very extempore. I just took the clean slate and just brought this question up. So give it a read and just think about it, if it is possible or impossible, and just try if you can prove it. So just pause the video and try that, and I'm going to straight away go with it. So I'm just going to clear my screen, clear the board. So according to this question, what if, let's say, let us consider that there are two whole numbers a comma b, which belongs to the whole number set. Then a square must be equals to 2b square. So we need to, so this is the thing. So, and it is impossible to find such two numbers. So if a square, so to get along with it, we just consider that a and b are co-prime numbers. So co-prime means that they don't have any common factor greater than 1. Okay, so if you move along in that direction, so another thing that, if let's consider that if a is odd. So if a is odd, then it is pretty obvious that there are no such numbers, there's no such b, that a square equals to twice b square, because we know that twice of any number is an even number, right? So, and we know that odd square will give you an odd number. So therefore, uh, there a cannot be odd. So let's consider that if a is even. So if a is even, then what do we have is that, let's say a is equals to, let a equals to twice c. Okay, so if a is equals to twice c, then twice c whole square will be equal to twice b square, which implies b square is equals to twice c square, right? Isn't it? So, and this implies that b square is even, and therefore b is also even. Fine. So I'm just again going to rub this off. So now, since a is even, a and b both are even, both even, therefore they both can be expressed as, a can be, a as we express as 2c, so b also can be expressed as 2d. So both have now got 2 as a common factor, which is greater than 1. Fine. And since 2 is a common factor of A and B, therefore we have a contradiction. We have a contradiction. What is the contradiction? That what is our contradiction? That A and B both are co-prime numbers, right? So, but we already, since they are co-prime, you cannot have a common factor more than one. But we have two as a common factor, and therefore we have a contradiction. And so, even in case of A being even, we cannot have, we cannot find a number, uh, a pair of number which are whole numbers such that A square is equal to twice B square, and hence A square equals to twice B square is not possible. There does not exist. And so this is the symbol of not possible. So this is how we actually try and approach for doing a proof. Even though this is the basic idea. So this is the beauty of the history of mathematics. Now it seems so obvious, right? That yes, we need to prove it. We need to go in a certain direction, but it was not that simple back in 600 BC. People used to just set a certain amount of rules, and they thought that these rules, which they proved, which they found out empirically, applicable at all the situations, and so they thought they were universal. But finally, Pythagoras was the person whom we should thank for coming up with proofs, and that proofs have become a vital part of mathematics now. So this was a very small example of coming up with a proof and making it clear that yes, we cannot find two pairs of whole numbers such that the square of one is equals to twice the square of the other. Thank you so much.